So we're now going to do multiplying and dividing with inequalities to solve. And so I'm going to start by telling you right now, case one, and that's this first page, is the one I need you to be really good at. Case one is the important one. Case one is the one that you've got to understand. Okay, case two is the one that even my high schoolers still struggle with. So if you struggle with it when I'm teaching it to you, then understand that you're going to keep doing it. You'll do it in 6th grade, 7th grade, 8th grade, 9th grade, 10th grade. Hopefully by 10th grade, that's usually when my kids start going, oh, I finally understand. So understand that my goal is that you understand case one. Case one, case one, case one. Case two, I'm going to show it to you. We're going to work with it. We're going to try our hardest. But if that's the one that you're struggling with, take a deep breath. It's okay. Okay, that's the one even my high schoolers still struggle with. But case one, I think you're going to be golden on. Okay, so case one is when you're multiplying and dividing properties of inequalities. You can multiply or divide both sides of an inequality by a positive number, and the inequality remains true. Okay, and so let me show you how this works. So this is being multiplied by 2. So I can divide both sides by 2, and that's saying x is less than 5. So if I go 5, 6, 7, 8, 4, 3, 2, open circle at 5, plug that in, and it's going this way. Now I'm going to use this. What I'm about ready to do right now is not really for this case, because I bet you're like, shut up, Beth, I get this. But what I want to show you is we're going to use in case 2 in a minute. So I can pick any number down here, like 2, and I can plug 2 in here. 2 times 2 is less than 10. 4 is less than 10. Yep. I could plug in 3. 3 times 2 is 6. 6 is less than 10. Any of those things. If I plug in like 7, 2 times 7 is less than 10. No, 2 times 7 is 14. It is not less than 10. So the shaded region gives me all of the answers that work for my problem. Anything that would work. Okay? So with that being said, I would like you just to do the opposite operation. I would like you to do number 2. I would like you to pause the video, and I would like you to do number 2, please. Okay, so the opposite operation of timesing by 7 is to divide by 7. So I'm going to divide both sides by 7, and I get a is greater than or equal to a negative 9. Okay, a is greater than or equal to a negative 9. So I'm going to take that thing, and I'm going to go negative 9, negative 8, negative 7, negative 6, negative 10, negative 11, negative 12, okay? And I have a filled in circle, and it's bigger than. Okay, so that means, I'm going to do this again. So that means, like, if I pick a number like 7, 7 times a negative 7 is greater than or equal to a negative 63. That's a negative 49. Right? And that is bigger than a negative 63 because it's closer to 0. Okay, so it's telling me the ones that work. And again, I'm doing the yellow part, not for right now, but for later. So on number 3, I'm dividing by 3. So the opposite operation of dividing by 3 is to times by 3. So I have 24, 25, 26, 27, 23, 22, 21, and I have a filled in circle at 24, and it's everything bigger than that, okay? So like if I pick 27, doing the yellow again, just to show you. So 27 divided by 3 is greater than or equal to 8. So 27 divided by 3 is 9, and that is greater than 8. Now if I pick 21, 21 divided by 3 is greater than or equal to 8. That's 7. Is 7 greater than 8? No. So the shaded region is giving me all the things that work. Okay, on number 4, I would flip-flop before you started because it's hard to graph these when it's not, the variable's not on the left. I would like you to take a second, and I would like you to do number 4. Finish it from here. So if I do this, I'm dividing by 4, so I'm going to times both sides by 4. So k is less than or equal to a negative 8. So negative 7, negative 6, negative 5, negative 9, negative 10, negative 11. So all of those are right. Okay, and I'm doing an open circle, and then I'm going this way. Okay, so anything on that side is going to work. Anything on the other side is not going to work. Okay, case 1. So it's it's the easy case. You're just adding or you're multiplying or dividing by a positive number and you just do the math like we've been doing. Okay, deep breath. Case 2. This is the one that, like I said, my kids still struggle with that I'm teaching. Okay, so if I do case 2, if I divide by a -7, don't write this down. I just want you to watch for a second. Just watch. Please just watch. If I do what I've been doing and I divide by a -7, okay, that's a -4, -3, -2, -1, -5, -6, -7, right? And so I would have a circle here and I'm going this direction. Okay. All right. So if I put in something over here, I'm going to use yellow. If I put in a -3, -2 times a -3, that's 21. Is 21 greater than 28? Okay. Same thing here. So, and I think I did the math right. -7 times a -2. That's 14. Is 14 bigger than 28? No. Okay, but if I come over here and do a -7, -7 times a -7 is 49. Okay, is 49 greater than 20? So it actually is shaded backwards. Okay, so I did the math right, but it's shaded backwards. So I actually am going to shade this thing this direction. Okay, because you're moving the X onto the other side. So since you're moving the X to this side to make it positive, it flips and it's less than. Okay, so this says the inequality, let's read it. If you multiply or divide a fraction by the same negative number, the inequality remains true by reversing the direction of the inequality symbol. Okay, you have no idea how many times I go over this in high school. So that's why I'm really taking my time on this. So if you divide or multiply by a negative number, it's going to be shaded the wrong way if you don't flip the sign. Because when you multiply or divide by a negative, you change the sign. So that changes the inequality. You have to flip this sign. So when you multiply or divide, you got to flip the sign. Okay, I hate how they do this. I wish they would be nicer. So I'm going to rewrite this case. It's pointed towards the end, right? Pointed towards the end. Okay, so just watch again. Just watch. I'm going to divide by a -3, divide by a -3, and if I don't flip the sign, is 6. So 6, 7, 8, 9, 5, 4, 3. I have an open circle at 6, and it says to shade this way. But if I take one of those numbers like 4 and I put it in there, 3 times 4, I get a -18 is greater than a -12. Well, that's not true. -18 is not greater than a -12. -12 is closer to 0. So my sign is wrong. So when I divided right here by that negative number, I needed to flip my inequality sign. Since I divided by a negative number, I'm changing the sign. That also changes the inequality sign. So now if I shade this way, let me pick a number up there like 7. -18 is greater than a -3 times 7. That would be a -21. And -18 is bigger. It's closer to 0. So when you multiply or divide by a negative number, you have to flip the inequality sign. Okay, so let's get these. If you need to pause and write all that down, that we flipped this sign, please do. Okay, so pause and get those written on your notes. We're going to do the next two together, and then we're going to do some practice. Okay, so on this one, I'm dividing by a -5. So if I multiply by a -5, the rule says if you multiply or divide by a negative number to both sides, so this is on both sides, I'm multiplying by this -5 on both sides, I have to flip the inequality sign. And that's a negative times a negative is a positive. 15, 16, 17, 18, 14, 13, 12. So I have an open circle at 15 and I'm going greater. Okay, so if I look at that, like 20 is greater. If I put 20 into this, that's a -4. Is a -4 less than a -3? Yes. So 20 is part of my answer. So I have to flip the sign. Okay, let's take a look at the next one. It's being divided by -2, so I'm going to times both sides by a -2, but I just multiplied by a negative number, so that flips the inequality sign because you're changing the sign, which changes the direction. So -14, -13, -12, -11, -15, -16, -17, -14 would have a filled in circle in its greater than. Okay, so you can pick a number to see if that's true. Like if I pick a -12, I would have a -12 over a -2 is less than or equal to 7. Negative over a negative is a positive, and it's a 6. Is 6 less than 7? Yes. Okay, so when you multiply or divide by a negative number, you have to reverse the direction of the inequality sign. You have to. Okay, so let's take a look at number 9. Number 9, to do this, I'm dividing both sides by a positive number. I do not flip the inequality sign. It stays. 8 is positive. I'm dividing by a positive, so it stays the same. So -6, open circle, -5, -4, -3, -7, -8, -9. So I would do -6, and it's less than, so it's going this way. If you want to pick a number to put in there, I could pick like a -8. So 8 times a -8 is less than a -48. That's a -64. And it is less than 48. -48 is bigger because it's closer to 0. So on that one, I did not flip the sign because it was positive. But take a look at the next one. I'm going to multiply both sides by a -4. Okay, that means you have to flip the inequality sign because this number that you're multiplying by is negative. So K is greater than a -12. So -12, -11, -10, -9, -13, -14, -15. And I'm going greater than, so I'm going towards 0. And if I pick a number that's in that area, like -8, right? I would have a -8 divided by a -4 is less than or equal to 3. Negative divided by a negative is a positive. 2 is 2 less than 3. Yes, so it worked. Okay, I would like you to try question 11, 13, 12, and 14. I would like you to try these, please. Okay, on this one, I'm dividing both sides by a negative number. It's negative, so you have to flip the inequality sign, right? So this is W, negative and a negative is a positive, 7. So 7, 8, 9, 10, 6, 5, 4. Open circle at 7. Sorry. Some of my kids in junior high, they teach to go above. It doesn't matter to me. And so it's going this way. Okay. On the next one, I would reorder it just so I don't mess up. So R over 9, it's pointed towards the R. So I'm being divided by 9. So to undo, opposite operation, I'm going to times by 9. And so I have 18, 19, 20, 21, 17, 16, 15. I have a filled in circle at 18, and it's everything less. Going that way. Okay, on this one, you're multiplying both sides by a -7. So that means that you have to flip the inequality sign. So that would be N, a negative and a negative is a positive. N is less than 28. So I'm going to fill in that circle, and it's going less than 28. Okay, and then on the last one, I would rewrite it. Now, this one, kids always want to flip the sign, but I'm dividing by 8, right? 8 is positive. That red number that I'm dividing by is positive. You do not flip the sign. You only flip the sign when you are -1, 0, 1, -3, when you're dividing or multiplying by a negative. So open circle, and I'm going less than, so it's this direction. Okay? All right, so we're going to jump down to these last ones. This is what we have been doing. It's yes or no. So if I take this 5 and put it in for M, I have 4 times a -5 is less than or equal to a -16. That's a -20 is less than or equal to 16, which is true. 16 is bigger. -16 is bigger than a negative 20 because it's closer to 0. Okay, so I would like you to do 18 and I would like you to do 20. On 18, since you're just filling in, you don't have to switch the sides, but if you did, it's okay, it doesn't matter. Negative 24 is less than a negative 24. This is like that one we did before. It doesn't have the equal to sign. It would have been a yes if I would have had that equal to sign, but I didn't. It's not there, so the answer is no. Then on the last one, negative 40 over 8 is greater than or equal to a negative 3. So that's a negative 5 is greater than a negative 3, and that answer is no, because a negative 3 is closer to 0, so a negative 3 is bigger.